I recently made a video about NASA's New Horizons mission in which a spacecraft visited an object in the Kuiper Belt, the most distant object ever visited by humankind. And it sent back a picture of that object, Ultima Thule, which is helping to understand the origin and formation of our solar system. This got me thinking about hypotheses in astronomy and the tremendous value of images and the tremendous clarity that they sometimes offer. Consider that for the first time in history, we can now formulate theories about the origins of our own solar system. And then we can support those theories with images of the formation of other solar systems. That's incredible. One of the things that happened in the last video is that I talked about the current model of planetary formation, about a protostar forming an accretion disk or a protoplanetary disk around it, out of which planets eventually formed. This amazing picture is an image of the protoplanetary disk around HL Tauri, which is a very young star, maybe 100,000 years old and around 450 light years away. In other words, 100 times farther away than the Alpha Centauri system, the nearest star system to us. This image was released in 2014. It was taken by an array of radio telescopes known as ALMA, Atacama Large Millimeter Submillimeter Array, located in the Atacama Desert of northern Chile. The idea that our solar system was born out of a protoplanetary disk originates in the 18th century with philosopher and evidently polymath Immanuel Kant, and later at the end of that century by the mathematician Laplace, who realized that the fact that all the planets in our solar system rotate around the sun in the same plane and in the same direction suggests that they all have a common origin in a flat disk of rotating gaseous material. But these ideas, prescient and sensible as they were, could not be proven at the time. My intention here is not to run through the history of what is known as the Nebular Theory and the concept of protoplanetary disks. It's to reflect on the fact that in science, we generally develop better tools to use to answer questions and to test hypotheses. I visualize Kant in the mid-1700s holding forth at a fine dinner with his male friends from the University of Königsberg in their powdered wigs, paying rapt attention as he imagines that our solar system must have formed from a coplanar gaseous disk rotating around the sun. It was a wonderful idea, but you couldn't blame one of his guests for asking, "But how do you know, Herr Professor? Will we ever know?" And then jump ahead 250 years when we can say, yeah, we can't exactly go back 4.6 billion years and look at the formation of our solar system, but we can look at images of this very process occurring in many other solar systems. What? How cool is that? One can say, well, check out these other protoplanetary disks around other stars several hundred light years away. I think Kant would be pleased, and a less sober man than he would be absolutely blown away. And this is not to argue that proofs of hypotheses in astronomy can only come from images. There's mathematical modeling, there are computer simulations, chemistry sometimes helps, etc. Nor is this a review of telescopes in astronomical exploration. But the fact that we sometimes have images to turn to much later to address long-standing hypotheses, especially images of elsewhere far, far away that teach us about our own origins, well, that's remarkable. Visual demonstrations have a powerful immediacy for us. Back to the Nebular Hypothesis. The accepted idea now is that stars form in dense and massive clouds of molecular hydrogen called giant molecular clouds. But when first proposed, nobody could actually see images of stars forming within giant molecular clouds. I imagine a scene which did not occur when two astronomers, let's call them Bob and Ted, in the early part of the 20th century, were enjoying a beer together at their local watering hole. And Ted says, "You know, Bob, stars form within dense and massive clouds of molecular hydrogen." Bob eyes him suspiciously and says, "Ted, you can theorize all you want, but I want data." To which Ted pulls out this Hubble image of a star-forming region in a giant molecular cloud and says, "Eat your heart out, Bob." Well, that didn't happen. But today, when we consider star formation, we're assisted in large measure by the clarity and authority of images like this one of star-forming regions. There's a long history of this process. When Copernicus realized in the early 1500s that the Earth goes around the Sun instead of vice versa, contradicting the Ptolemaic system that had been in place for 1400 years. He made drawings, illustrated his ideas, he made arguments, but he couldn't prove it. A powerful visual argument came about 100 years later when Galileo pointed his telescope at the planets and saw what are now called the Galilean moons and the phases of Venus, which were not compatible with the Earth at the center of the solar system. It's not hard to imagine that such powerful imagery would need to be suppressed by the Church. An entrenched power, feeling threatened by new information not consistent with its own schema of the cosmos, might seek to suppress that information. But telescopes were not solely in the hands of Galileo, and knowledge can be suppressed only temporarily. And by the end of that century, the general public could read about the heliocentric solar system. The point being that there's a long history of dramatic images of distant objects altering our understanding of our own situation in the universe. And I wouldn't argue with you if you want to say, well, that's part of the whole history of astronomy, going back to the days of early human beings gazing up at the stars at night. But what is unprecedented is that now, for the first time in history, we can try to understand our own solar system by looking at images of other solar systems mind-bogglingly distant from us for confirmatory evidence. That's pretty fascinating. Next week, I want to show you some more astronomical propositions and images that illustrate this process. And some of them are quite spectacular. So don't miss the exciting conclusion. Be sure to subscribe. You can follow my Instagram. And thanks a lot for watching.